with announcements. Listen closely. Some of these could potentially be bonus opportunities. Yours is it, but you have other things to talk about. Don't you? Oh, look, I have a calculator.
Shoot. You were supposed to remind me. Hold on one second.
All right, let someone else go while you go find your email.
I forgot.
Okay, we have an SI session tonight because I hope you're not surprised by the fact that you have an exam tomorrow. So you should probably come to an SI session and learn chemistry because it's way, way cooler than like class. No, I don't think it's cooler than class. Class is definitely cooler.
Also, Srav sent out the practice problems, so I hope you guys take a look at those before tonight. And hopefully it's already posted. Has anyone checked? There should be a SI documents thing. Oh, it's up. Good. There's a review sheet that I made for chapter 18 and 19. It's scanned and put up on Blackboard. So make sure you take a look at that. It's not complete, but it's kind of some of the main points. So go ahead and print both of those off for tonight. Try and look at them, and also look at the suggested problems from chapter 18 that Dr. Kenney gave you. And now someone else, and then I'll
Look
come
at
back.
98% of...
What's up?
What's up?
Okay. Friday from 2 to 4, the Case Lacrosse Club is going to be throwing a Friday sampler kind of event. I personally will be in the goal, so if you really want to, you can come take some shots at me. There will also be freeze pops, possibly hot dogs, maybe some hamburgers, and there will also be lots of love. So please, if anything, come for that.
2 to 4, aren't you supposed to be in class?
There's no class on Friday.
Oh, there's no class on Friday, that's right. Can I throw a ball at you?
Mm-hmm.
All right. You have your equipment with you? Oh, good.
The Pre-Dental Society is doing a dental hygiene drive, and we are collecting supplies to distribute them to the inner city elementary schools in Cleveland. So we're collecting like floss and toothbrushes and toothpaste. So if you guys haven't already gotten supplies, if you could get some and bring them to your testing sites tomorrow, and there will be people collecting them, and you will get a bonus point for them.
Please don't bring used supplies. I hope that's an obvious statement, but...
And last but not least, this is from the Center for Civic Engagement and Learning. Saturday, April 19th, is the Saturday of service, so it's kind of a campus-wide drive to all of us just kind of go out and do something in the community. So this is this Saturday. You can see that you have to register by Thursday, which is tomorrow. So go ahead and go to this website. Please write it down. And you can register.
You can post it. We'll post it.
Yeah, we'll post all this information to Blackboard. But it's Saturday of service, this Saturday, April 19th. The weather should be fine. And there's a bunch of different service opportunities. You can sign up online. And here's what the website is. So you can see all the different opportunities near the area. Some canceled, sorry. But all the different opportunities, and then there's also a registration page. So go ahead and give something back to the community this Saturday. Remember to register by tomorrow.
Please do register, write a reflection on it. This is to replace a blood donation for some people, but this is one that I'll open to anyone. So if you participate in Saturday of service.
Bonus.
Okay? No, not one per hour. I would like you to bonus for or to volunteer for a minimum of 2 hours, and that's worth a bonus. So every instance is a bonus, but a maximum of 2 on these. Yes, those of you in the Greek system already are doing service as part of that too. You can double dip. So yes, if you're doing that.
Someone asked if this was the only community service for people.
This is not the only community service that you could do. You could do any community service. I know there's several of you that are tutoring on a regular basis. That's great. I will absolutely give you credit for that. So if you're going to one of the local churches and tutoring regularly, please keep doing that. It's a great way for you to pay back some of what you've received over your life. So other opportunities going on. There is a Kung Fu, is somebody in the Kung Fu Club? The martial arts tournament this weekend. I encourage you to go to that. Yes, you can consider that one of the sporting events that would qualify. There's believe me, between now and when you finish your exams, there are so many things going on. No, Spring Fest is not a bonus opportunity. I do expect to see most of you at Spring Fest, though. I'm rumored to be there, although I'm not exactly sure what I'm doing yet. Somebody said something about throwing things at me, but I can't remember. Yes, show up at the softball game. When is the softball game? Where are they? Where's home? The new field? Which field? By Clark Towers. Okay, you guys know where it is. I don't. It's over in the village? All right. So softball is at home this weekend. Check them out. Lots of opportunities. Nobody should leave this semester without all 10 bonus points, is my opinion on this. So there's lots of opportunities for you to do that. Other questions? Yes? I will try to remember to post them to Blackboard. It's quite honestly, it's not as high on my priority list, but I will try to make time to do that. I had to write a test, I guess. I just handed it to my secretary on the way here. So the test is actually written to this time. I can tell you exactly, question for question, what's on it. Other questions? I will. Mary. A chemistry question in chemistry class? Before we do that, there was this cool lab that I just got to see, folks. If you didn't know it, Jackie Sung, who's over in mechanical engineering, I don't know which one, has a combustion lab where he studies combustion. And think about this. You want to measure all the stuff in a flame. How the heck do you do that? He does it with lasers. He does it with other stuff. He's got this great big monster apparatus to be able to have the single injection in a car engine. But what was really cool is he's got a 350 Chevy, he's got a diesel engine, and he's got a motorcycle engine all hooked up so that he can be doing experiments right on those. It was a really neat lab. So if you get a chance to check out what Professor Sung is doing over in Glennon, it would be well worth the time. Just drop him an email and say, Dr. Kenney said I should contact you. There's some cool stuff. Somebody else wrote me a question, an email about batteries. The answer is yes, but I got to remember what the question is. So, what's on the test? You want to ask a chemistry question?
Okay, so we have the equation that says the electron force is proportional to the free energy, and then this, like the standard hydrogen electrode has much more force than zero. So why does that reaction even happen?
Okay. Can you get rid of the screen for me? And give me some more light. Actually, I think you know the answer to this question already. The question is, if the cell electromotive force, if E0 is proportional to the free energy, and the proportionality or the equality is delta G equals negative NFE. So if we want to know the delta G for a reaction, if we can measure the cell potential for that reaction, all we got to do is multiply by the number of electrons and the Faraday constant, we can get a delta G. And so the question is, if the half cell potential for hydrogen is 0, therefore the delta G should be 0 as well, right? So, how can that be? I'm trying to think of the right adjective. It's a great question because it really drives home the fact that everything that we do is referenced back to hydrogen. So, if I ask you, what's the free energy of formation of hydrogen? 0. You start with hydrogen gas, you make hydrogen gas. And so the free energy of formation of hydrogen gas is 0. All right, but the electrochemical cell for hydrogen has more than just hydrogen gas in it. The standard hydrogen electrode is this. And so if we want to calculate the delta G for that reaction, could we calculate a delta G for a half-cell reaction? The answer is yeah, you can. You would talk about the delta G of formation of the products minus the delta G of formation of the reactants to get the delta G of the reaction. Well, we already know the half-cell potential for this reaction is 0, and it doesn't matter which direction I write it. Therefore, delta G, 0, has to be 0. And since delta G I'm missing the sum, of a reaction is just the sum of the delta G's of formation of the products minus the sum of the delta G's of formation of the reactants. Well, we take this reaction and we say, okay, delta G for this reaction is equal to the delta G of formation of hydrogen, gas, plus or minus I have to have a 2 in there because there's 2 hydrogen ions, right? The delta G of formation of hydrogen ions minus and that one looks kind of strange, but we're going to put it in there for completeness. Okay? So, what's the delta G of formation of hydrogen gas? 0. This is equal to 0. So if I follow this through and I do the algebra, what it's now saying is, okay, I'm going to bring one of these to the other side. I get the delta G of formation of hydrogen ions is equal to the negative delta G of formation of electrons, right? If I did my algebra right. H plus is just a proton. So I'm stuck now, though, because I still have 2 unknowns. I have no way of doing this. I'm sorry? No, I can't. I can factor the 2 out, right? There's a 2 in front of each of them, so I just got rid of it. So I still have 2 unknowns, and so in the end, there's no way to separate these. I can't do it. But I'm going to pick on hydrogen again. What's the delta G of formation of hydrogen ions? Let's keep it simple. 0. That's our reference point. The free energy, or the delta H of formation of hydrogen ions, is 0. It's the only way we can get free energy changes or delta H's of formations for ions. We have to have one that everything else is referenced to. Now, if someday somebody comes along and convinces all of us that it really should be 1 kilojoule, all that's going to do is change all our numbers. It's going to move them from here up to here. It will do nothing else. It won't change any of our theories. We're just artificially, well, what does that mean the delta G of formation of an electron is? 0. So it's just an arbitrary point because we can't figure it out absolutely. There's no way to separate them. No matter how we do this, we always have to have one where we've artificially set the value, and this is the one we pick on. Does that answer your question? It doesn't satisfy you. Does it answer your question?
Well, but can we still say that that our value for G is going to tell us if it's spontaneous?
Yes. Is this reaction spontaneous? No, it's in equilibrium because delta G is equal to 0. It's not spontaneous. Wait. Okay. If delta G is less than 0, it's spontaneous. If it's greater than 0, it's non-spontaneous. And if it's equal to 0, it's equilibrium.
There's a bunch of equations relating E and delta G to equilibrium constants.
Yes. Yes.
Do you memorize those equations?
They're on the equation sheet. Yep. The Nernst equation, E equals E0 minus 0.0592 over N, or RT over NF times natural log of Q. It's on the equation sheet.
The one for entropy on electricity?
I think so. For entropy? Cell potential? Yeah, I think so. We'll just make sure here. Little musical interlude while I'm getting to Blackboard. I need to have an iPod that I just hit play on every once in a while, right? Speaking of iPods, Jess, weren't you going to sell it to me? Well, come by. Let me evaluate the product. Okay. Documents. Didn't I put the equation sheets on here? But you haven't? That's all right. I put it on there last semester, right? I haven't added. It's the exact same equation sheets. If you've got yours there, I'll take a look at it. But I'd like to be able to put it up here so you can see it. Here we go. Part of the reason I put it here is so I'd always be able to find it, and then I forgot where I put it. Does that sound familiar or what? I know you can't see it. I'll fix that. Yes? That the one you're looking for? You think so, right? It's in the bottom left-hand corner of one of the two pages. I'm sorry? This is RT over NF. That's the script F is Faraday. And if I remember right, Faraday's constant is right there. So it's given to you on there. I even give you the gas constants, 8.31 volts per coulomb. And if you compare that one, can you see that? Yes, you can. If you compare that constant with this one up here, they're exact same value. The only difference is the units. So you can remember that 1 joule is equal to a volt coulomb. So you don't even have to memorize that. So everything you need as far as electrochemistry is right there. We skipped that part. Current equals charge over time. So I did not do that. Electrolysis is not on there, so you don't have to worry about that. But the rest of these, this is the equation. This is the Nernst equation in several different forms. Use the form that's most comfortable to you. Okay? If you don't think, I see Emma, if you don't think you're going to be calculating half cells potentials or cell potentials on this test, you haven't been doing problems. Catherine. I'm sorry? Is there a question? One more time. Sure. I can do that. Anyone in particular? Let me see what I got. Emma, what was your question? Which one? 66 of chapter 19? Oh, before I do that, let me answer a question that I keep forgetting to answer. Why is that screen not going up, Jess? That would do it. Use the one that's labeled screen. Heaven forbid. When we first came back to balancing oxidation reduction reactions, I gave you a set of steps to balance them. Balance the atom in question, balance the oxygen by adding hydrogen, balance the hydrogen by adding H+, balance the charge by adding electrons, and if it's in basic solution, neutralize the H+ with OH-. Okay? And ends up our book doesn't do any of these. They never tell you basic solution. So if I gave you this reaction, I'd do it something like this. Balance this half reaction and do it as though it were in acidic solution, which means it's okay to have H+ or not in your balanced equation. There may or may not be H+ in there. Okay? All acidic solution means is it's okay to have it there. If instead I said it's in basic solution, then there better not be any H plus in your reaction when you're done. Because H plus present is not a basic solution, it's an acidic solution. So if I want to balance this one as though it were in basic solution, and I can do this with any equation, follow the steps. First, balance the atom in question. In other words, the atom that changes oxidation state. It's usually pretty obvious which atom changes oxidation state. In this case, I hope you can all guess, I bet it's chromium. Since it's the only product that I have up there, it must be the chromium. Okay, I need 2. So I have now 2 chromium on both sides. Balance the oxygen by adding water. There's 7 on the left, I need 7 on the right. Balance hydrogen by adding H plus. There are 14 hydrogens on the right now. I need 14 on the left. Balance the charge by adding electrons. I have a plus 6 on the right. On the left, I have a plus 12. Minus 2 and a plus 14 is a plus 12, so I need 6 electrons. And if this were an acidic solution, I'd be done. Most of the time, you could quit at this point. If I happen to have a reaction, for example, if I balance a nice simple one. This one, hopefully, you can all do it by inspection now. There is no oxygen, there is no hydrogen. All I got to do is balance the charge. It wouldn't matter if this was acidic or basic solution because it would still look like this. There's no O or H in there, so we don't have to worry about it. So this one's now, it tells me it's in basic solution, it's balanced, but now because I can't have H plus in there, I have to neutralize the H plus. So the way that I neutralize those 14 H pluses is by adding 14 OH minuses. H plus plus OH minus gives me water. So these 14 OH pluses become 14 waters. I add 14 hydroxide to this side, and then I simplify it again because that usually messes it up. It's still balanced, but now there's no H plus around, so it's in basic solution. So that's all that means. I think it's balanced, right? I have a plus 14 or minus 14 plus. I have a minus 8 on the right and a minus 8 on the left. It's balanced. Why did I didn't move all the H2O to the left. I had 14 of them after I neutralized the H plus on the left, and I had 7 on the right. So I just got rid of the ones. I don't need water on both sides of the equation. Okay? So I just got rid of the redundancy. So that's all it means is if it's in basic solution, get rid of the H plus. Okay? Does that make sense? Okay. Problem number 66 or 64 from chapter 19. I have a feeling this will do what you want, Catherine. Oh, this one's a piece of cake. Who wants to do problem 64? I'm sorry? No. Which of you wants to come do it? How many people have not taken Chem 113 yet? Those are the only ones who shouldn't be able to do problem 64 or 66 because it's exactly the same as your potash experiment. It's exactly the same. What's the potash experiment? Sodium carbonate. How much sodium carbonate is there in your unknown? And you did a titration. It's the same problem. I'll show you in a second. Let me do problem 22 first. Where the heck did that come from? Is that the kind of question you were thinking of? With an equilibrium constant? Okay. I put 90% of the words from the problem up there because half the time people are getting hung up on the way this author writes some of his questions. And first of all, please don't blame Professor Chang for the way the questions are written. Most textbook publishers hire someone else to write the questions. So they hire someone like me to write the questions for his textbook. No, I did not write his questions. I did solve all his questions, but I didn't write his questions. So, strontium and magnesium react. Strontium metal reacts with magnesium ions to form strontium metal, or strontium ions and magnesium metal. In other words, strontium is oxidized by magnesium, which is reduced by strontium. Okay? The K for this reaction is 2.69 times 10 to the 12th. This is a very likely reaction to occur. It's going to happen, folks. Therefore, its E better be positive at 25 degrees C. Calculate E0 for the cell. You could put a period right there and be done. You don't need the rest of the information. But the rest of the information is added for completeness. It's also added to say to the student, what does this mean? Do you care? Made up of a strontium ion and magnesium ion half cell. What this is getting at is there's two ways to solve this problem. One of them would be to do the obvious thing. We'll do the obvious one, right? Look at a table. So there's my two half reactions. But wait a second, you say. That last line of what you wrote up there says strontium ion, magnesium ion. Why the heck do you have one of them reversed? The reason I have one of them reversed is because I know that I have to have both an oxidation and a reduction when I partner them together. When I look at the equation they gave me, the chemical equation, the full cell equation, I already know that the magnesium ions are going to be reduced to make magnesium metal. So let's just go ahead and reverse that reaction now. Because now when I look up the half cell potentials, I'll know that whatever the table tells me about magnesium, I'm just going to change the sign. And then once I've changed the sign, I can just add them together. I don't have to remember this formula that says blah, 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 minus blah, blah, blah. Okay, remember that equation in the book, if you choose to use it, you do not change the sign when you reverse the half cell, which is why I don't like it. I'd rather you remember that if you change the direction of the reaction, you just change the sign. That's the fundamental concept. But if you use the equation in the book, you don't do that. Okay? That's how it works. Essentially, you're doing the same thing by the minus sign in the equation. All right, I don't have the half cell potentials. They're being copied for your test. So, yeah, there, Susie, right handy. All right, strontium to strontium ions. Actually, I should look for strontium ions to strontium. They're probably not on the table. Oh, there it is. Strontium to strontium ions is 2.89 volts. And I know magnesium's on here. Negative 2.37 volts. Plus 0.52 volts. Okay, that's the answer. We're done. But it really defeats the purpose of the problem by doing it that way, doesn't it? It's a much easier problem doing it that way. Huh? The book gives you a different answer. Heaven forbid. What's wrong? What did we do? Oh, I screwed up. I did it wrong. No, I still think my answer's right. Why is my answer right and the book answer's right? How can they both be right? Susie? If I reverse them the other way, I'm not going to have the reaction that I started with. I'm going to have the opposite of it. And the cell potential of the reverse of that is negative 0.52 volts, right? That's under standard conditions. That's 1 molar concentrations of everything. The book, the problem says nothing about what the concentrations are. And so yes, that answer is correct if I've got 1 molar strontium ion and 1 molar magnesium ion. But I don't necessarily have that. Instead, I know that the equilibrium constant, which is equal to E cell, which is really what we want. We don't want E0 cell, we want E cell. We don't want standard conditions, we want the conditions of the problem. All right, so then how do we do that? Doesn't it ask for E? I might have wrote it wrong. Did I write E0? And if I read the problem in the book, it says, oh, it says calculate E0. So that means that the book is wrong. Because the value it gets for delta G, heaven forbid I call Professor Chang wrong, right? Well, let's use the equation and see what it says. It says E0 cell equals RT over NF times natural log of K. I could do the 0.0257 over N if you want, but then it's log, right? Is it natural log still? Okay. I never remember that number. I learned a completely different number. T, 298. N, 2 electrons. F, times natural log of to the 12th. Now, is the purpose of your question really, I didn't get the answer that's in the back of the book, am I right? Is that what? No? Okay, good. Ooh, there's a second hole down there. Goes even deeper. All right, this is where we need a calculator. Zane's out here madly punching buttons while my calculator worker here is busy on Facebook. Not that I'm singling you out or anything, Amelia, but were you on Facebook, by the way? No, I didn't see it. I just assumed, and you know what happens when you assume. Never mind. What'd you get, Zane?
No, I accidentally.
Oh, you put the wrong buttons.
Yeah, I forgot to multiply that.
0.37? Is that what it says in the back of the book? It's very, folks, let me give you a little hint. If all your friends are getting the answer in the back of the book and you're not, the odds are pretty good that they're better at punching buttons on the calculator than you are. Don't worry about it. Don't worry about the final answer. As long as you've set it up. If you get it to that stage, you're going to get all but 1 point. I have to make sure the TAs do that. There are 9 questions on this exam. Each question is worth 6 points. I will throw out 4 points and then double your score. So every question on the exam is worth 6 points. Equal weight to every question, which means there's at least one question that's a piece of cake. There's another one that is really tough. And I didn't put the one on that I was going to, but I still might. Anyway, I doubt it. It's being copied right now. 9 questions, 6 points each. That makes it easier for the TA to grade. They don't have to say, okay, is this an 8-point answer or a 6-point answer? It's either, you either got it all right, mostly right, almost all right, or it's all right. So it makes it easier for them. And then all I'm going to do is after we add up the scores, I'm going to double it, and the maximum score you can get is 100. So if you get 50 out of 54, guess what? You're going to get a perfect score on the test. You got 4 points to throw away. So if you find out there's one question you don't like, but you got all the rest of them, you just scored a 96 on the exam. So this is my way of saying, okay, if you've done problems, and there are several questions that say explain. I bet half of you in this room, I bet any 5 of you could sit down together and write every question. Any 5 of you could get together and you'd be able to write every question that's on there. Hopefully I've been that obvious. I've tried to be that obvious this time. Oh shoot, I forgot one. Oh well. Do it now? Now, I know what I'm going to do with this other one. I'm going to give you a take-home question after the test. And the way I will use that, I have to figure out. But I'm going to give you a take-home question because I really like it. I had to destroy something to be able to do it. So put it on Kappa. Put it on Kappa. Shh. I'm sorry, are there going to be any? That's the one that I forgot to put on it.
Can you make it a Kappa question?
Well, that's what I'm thinking, is I can make it a Kappa question.
Yeah, make it Kappa.
You'll like it. It's fun. What? Oh, of course you can work it with. No, you can't work with anybody if it's take home. I won't let you work with anyone else. Of course, if you never tell me you worked with someone else. Now, the Academic Integrity Board would tell me I have to be very clear. So let me be very clear. If I ever give you a take-home question, quiz, assignment, whatever, I expect you to work with other people. I would never forbid it. In fact, I gave a take-home test in a class once, and the first page said, you may ask anyone you want for help with these questions. All I require is that you show them this page. And I got more phone calls from professors saying, can I really help them? I said, yeah, help them. That's the whole idea, is so they learn. I don't care how they learn it, they learn it. You're not just going to give them the answer, you're going to make them figure it out. So they did. And that was the best. The only thing bad about that test, let me pick on a group of students at a large Midwestern state university with more than 40,000 undergraduates. This was a junior level PChem class that all of those students who wanted to go to a postgraduate program to be an MD would go to. And there were 100 students in the class, and I got 42 papers back that were verbatim the same answers. And they wanted to know why I was only giving each one of them 2.5 points. I said, well, you gave me one answer, so therefore I'll split it between all 40 of you. And they said, but you didn't say we couldn't work together. I said, no, I didn't say you couldn't work together. You can't copy each other, though, God darn it. So I got 100 points here. I'll give you each 2.5 points. How's that sound? And they were really ticked. You would be too, but would you copy verbatim someone else's answer? No, of course not, Dr. Kenney. Don't knock me, no. You'd never catch me doing that. Not on a test, no, heaven, even if it's a take-home. So I learned my lesson on that test. I will give take-home tests again. But I will state that every answer must be in your words, and if there is copying, you will share the points.
What if by chance you have the same?
You tell me what the chances are. If you get enough monkeys in a room, you can reproduce Shakespeare too. Not that you guys, never mind. There is no Q equals I times T. Do you not believe me? Hopefully you have that much faith in me that I would not lie to you. I may not completely tell you everything that's specifically there. I don't lie. Just to you? Well, here, let me shut off the microphone so I can explain it to you.
This first sentence. Because you said current is not dependent on voltage.
Because electrode potential depends upon ion concentrations. Okay. The question that's being asked is, there is a statement in the book that says that electrode potential depends upon concentration. And the answer is it absolutely does. That's what the Nernst equation is saying. The Nernst equation says she's back on Facebook. No, it's email now, okay. That's the Nernst equation. There was a great question that I assigned to you that was about hydrogen ion concentrations, and the last part was explain how you'd use this to make a pH electrode. The cell potential that you measure for any chemical cell is, if it's under standard conditions, you will get E0. That's pretty obvious. We've said that a couple times. But most chemical reactions are not under standard conditions. Well, let's think about Le Chatelier's principle for a second. Reactants, products. I've got lots of reactants, not many products. Le Chatelier's principle says you will move from reactants to products. Well, if that's the case, you're moving electrons. So your voltage is going to be higher than it would be if you're at an equilibrium situation. And so yes, cell potential does depend on concentration. That's how you make concentration cells. Where did I read this question? It's the mercury one. The one that has you calculate whether or not it's mercury 1 or mercury 2. What is that, 60, how much? 76. The question says, there's been a debate for years as to whether or not it's mercury 1 or mercury 2 with a +1 charge. So Hg +1 or Hg2 +2. Either way, it's mercury +1. And so they said, okay, let's set up a reaction where we've got one cell, one half cell, with a certain concentration of mercury in it, and then another half cell where you've got a 1/10 the amount of mercury in it. And so if you think about that for a second, what's going to happen is you're going to go from the high concentration to the low. You're going to force the reaction a certain direction. You're going to try to get back to an equilibrium state where everything's the same concentration. So if you use this Nernst equation to solve this problem, what you're trying to figure out in that, and you have to think a little bit to get to it, but really what you're asking is, what is N? What is the number of moles of electrons that are moving in this reaction? Because I can calculate E0 cell. I'm going from mercury to mercury. It's equal to 0. E0 for that cell that is set up is equal to 0. It gives you a value for E cell, and so you measure the cell potential, and then you say, okay, I know Q even because I know the concentration of products divided by the concentration of reactants, and it was equal to 0.1, so you get a negative value. The only thing you didn't know in that whole calculation is what is the value of N. And so by solving for the value of N, hopefully you found out that N is equal to 2. Because when we go from mercury metal to mercury ions, we find out that there's 2 moles of electrons that move, even though it's a +1 oxidation state. And so that's how we know that mercury is not Hg with a 1+ charge, it's Hg2 with a 2+ charge, which means its oxidation state is still +1. So that was a great question because it's going to take you to the basic level that says, okay, here's 2 half-cell reactions. Can you figure out the overall cell reaction? And yes, there's at least one question on there that asks you that. To a higher level that says, okay, now that you know that, here's a way to use it. Can you take that simple concept, can you take this reaction and understand what it says and apply it to a practical problem? And if you can, you will do phenomenally well on this exam. If you haven't been doing problems, do problems. Okay? Is that clear? If you haven't been doing problems, do problems. That's my advice to you tonight before tomorrow. Speaking of problems, what is the partial pressure it gives you? Always. 1. Oh, good. They're very nice to us. You know, if I take the ideal gas law and I say PV equals nRT and I solve that and rearrange it so I get natural N over V, concentration, is equal to pressure over RT, that would tell me that I should take that pressure and divide by RT to convert it to a concentration, right? And if you did that, you had the same thing happen to you that happened to me. You got an answer that disagreed with the back of the book. All they've done in all those problems, and it didn't hit me until I started looking at it and saying, oh, look, they're always giving me 1 atmosphere of pressure. They're just dividing by 1. There's one that doesn't. Which one? What page? 659. All right. Example 19.7. Consider the galvanic cell shown in the figure 19.4. In a certain experiment, the EMF of the cell is found to be 0.54 volts. Suppose that Z... I'm sorry? It's the one after it. What is the EMF of galvanic cell? If the pressure of hydrogen is 0.8 atmospheres. Ooh. Did you try it by converting it to concentration? Or did you leave it as 0.8? Natural log of 1 is 0, right? It doesn't work. I'll tell you what, let me look at that practice exercise and I'll post you something late tonight as to what I think about it. Is that fair? All right. Got a pen? Perfect. Oh, I like these pens. Oh, looks like it's quitting time. I will see you tomorrow. Mary, what's up? There's nobody in here, so if you want to hang around for a minute, that's fine.